class. We are doing a video today for a review instead of meeting on Google Meet. So I'm just going to make the video because I had some people in the class call in and say, hey, we can't be there at any time on Thursday. I work 9 to 3 or whatever. So that's fine. I'll just do it on a video. But I am using new technology, so we'll just see how it goes. Remember, I can only do 15-minute uploads on videos, so I'm going to just go till 15 minutes, and then I'll do as many videos as necessary. I might not get the other ones completed until tomorrow because it's near the end of the day, and I've been in meetings all day, and so I might get the rest tomorrow. So we'll just do one today, and then I'll figure out how to get the rest of them in another day. All right, first one we're going to do is number 2, and it says, during the worst periods of hyperinflation in a certain country, the price of food increased at a rate of 25% per month. State whether this increase was linear or exponential, and if it's going up by a percentage, a rate, so the rate would be 0.25, the percent is 25, then that's going to be an exponential function. And then the next part says, what was the monthly food bill after 3 months? So in order to do that, we're going to have to use a formula. And I think, let's see, to find it, it's 1 plus R, right, times your initial amount, which was 130 in this case. So 130 is month 0. Month 0 is 130, and we multiply that by 1 plus 0.25, so it's 1.25 to get the next month's food bill amount. So we have 130 times 1.25. And that's 162.50. It's going to be your next bill. So month 1 is 162.50, and we times that by 1.25 again. Luckily, we already have it in our calculator, so we can calculate the next month pretty easily. 125. So month 2, I have to go to month 3, but month 2 is going to be 203.125, and we times that again by 1.25. And that is 253.91. So 253.91. Let's see, that's initial. That's 123. So that's it. Month 3 is going to be that. 253.91. Oh, and it says round to the nearest dollar as needed. So that's going to round up to 254. I don't really want that up in there. 254. All right. Hopefully that's right. Woohoo, we got one right. Okay, number 3. This is the king one. I love the king one. All right, so as you know, they're placing 1 grain of wheat on square 1, and then it doubles to 2 grains of wheat on square 2, and it's asking how much, if we do that, and it continues doubling, how much will we have accumulated on the board on square 60. So 60. Now, if you recall, the first 60 squares, that if we had a formula and it was 2 to the 60 to the nth power, and then we subtract 1. And that was the formula, if you recall. 2 to the 60 subtract 1. Whoops, remember to arrow out of the exponent position before you subtract 1 on your calculator. And that is approximately 1.15 times 10 to the 18th. All right, that is how many grains of wheat are on that board. It's probably going to crush by the pounds that it's weighing down with, but then we have to find the pounds. So the pounds are going to be pretty easy to find because we know that each of the grains of wheat weigh 1/7,000th of a pound. So if we just take this amount of grains and divide by 7,000, that's going to give us our weight in pounds. And we have it in our calculator already, which is really nice. So you can just divide by 7,000 and we get 1.65 times 10 to the 14th now. And that's in pounds. That's how many accumulated grain, how much they all weigh together. Now, that's in pounds. We want it in tons at once. And that 1 ton is 2,000 pounds. So if we want it in tons, we have to divide by 2,000 pounds. So our pounds divide away. And I'm going to do that on my calculator. And on my calculator, I got 8.235 times 10 to the 10th power. All right. Now, the hard part about this problem is this last part. It says round to 6 decimal places and put it in scientific notation. All right. Let's see what happens here. So scientific notation, gosh, you click on that once and it just keeps coming up, doesn't it? Not bothering me. All right, 8.23515. We have to go to the sixth place, and I think that's 5 already. 5, and then next is a 3, 6, so that's going to round to 4. So 8.235154, and then we have to use our little times from our, how do we get that back? From the palette. Why did I tell me it's going to let me have that back? Where's my palette? You know, I am not capable of finding my palette again. It says, why did I get rid of that? Oh, thank you. Inept teachers. Times 10 to the, what does it say? 10 to the 10th power? Oh my gosh, I just got rid of that and I can't even get it back. I just cleared it. I hope that I have this right. Oh, this is great. Great fun. 10 to the 10th power. I'm hoping I remembered that right. Oh, I did. Imagine that. Okay, that was number 3. Woohoo, we've done 2. Now we're on 4. Oh, the leprechaun problem. A leprechaun places a magic penny under a girl's pillow. The next night, there are 2 magic pennies under her pillow. Each night, the number of magic pennies doubles. How much money will the girl have after 24 nights? Okay, we are going to have to do a little figuring here. So 24 nights, if you recall, it's doubling. 2 to the, every night it doubles. So we have to raise 2, the doubling, 2 into the power of 24. All right? And that's going to be how many pennies are there. Once we get that number, we have to figure out the cost. We'll do that in a minute. Let's figure out what 2 to the 24th power is. So 2 to the 24th power is 167777216. That's how many pennies there are. Okay, so 16,777,216 pennies. Now, if we multiply that by 0.01, because each is worth a penny, remember it asks us how much money. So we have to say that our pennies are worth, our pennies are worth 1 cent. So we're going to multiply that amount, times by 0.01. And that will be, if I click in here, let's see. Does it say to round to anything? I think that's about right. So $167,772.16. Woo! That was right. All right, the next problem we're going to do is 7. All right, 7 says the half-life of a drug in the bloodstream is 9 hours. What fraction of the original drug dose remains in 12 hours and in 48 hours? So, if you recall what we do with this, we're going to deal with half-life. So, half-life, the formula is 1/2 raised to the power of little t over half-life. All right, so we're given 2 different problems to do. First one, after 9 hours, is going to be, I'm just going to write 0.5 because that's how I'm placing it in the calculator. Little t is 12 hours to 9 hours for a half-life. And then the other problem we're asked to do is what happens after 48 hours. All right, and that's what you're going to just do in those. So 0.5, I'm going to put in parentheses on my calculator. 0.5 to the power of 12 divide 9 is approximately 0.396, so that just rounds to 0.40 because it's nearest hundredth. And then I'm just going to go extract it and change the 12 to 48, and I get 0.02. And that's what we're going to put in. But I have to get out of that, click on that, and hit 0.40. All right. And then the next one is going to be 0.02, did we say? And that's how you do that one. Oh, we're moving right along. All right, next up is number 8. We'll do number 8. Use the approximation half-life formula for the case described below and discuss whether the formula is valid for the case described. So approximate. If you recall, the approximate is the rule 70 divided by your percentage, which in this case is 70 divided by 6%. And we just leave it as your percent. So when I do that, I get 11.7. All right, so that's halftime. All right, and then the next one, that's the half-life, so I guess we could type that in, but I'm just going to do the rest of the problem, then I'll type them in a minute. What fraction of the force will remain in 10 years? So in 10 years, then that's going to be little t, and we use the same formula, so 1/2 times little t, which was 10 years, divided by 11.7. All right, so in parentheses, 0.5 to the power of 10 divided by 11.7. And that is 0.55. Yeah, I was looking at it thinking it should have been about half a year, and it should be because you have a decimal that you're raising. What? Oh, I gave the wrong. I answered the second question first. The first question is 10 because that's asking for the half-life. Didn't I get 10? Oh, I didn't. I'm going to get this right to say it. I actually was thinking about another problem. 11.7 is what we got, right? When we, wait, what does it say? Nearest hundredth, so 6, 7. And it was asking for half-life, right? Let me make sure. Yeah, the half-life we got to be 11.67. This is my final check. Got it right that time. All right, after 10 years, that's what I was thinking, little t, but I was really just trying to hurry. So, all right, fraction of the force will remain after that. That's where we got our 0.55. Oh, nearest thousandth. So 0.5529 rounds to 0.553. Okay. What did I do wrong? Did I do 10 divided by? Let's see. 0.5 to the power of 10 divided by, I'll just go up and extract that. 0.552. If I put in the exact number. All right, I kind of wanted to show you why I got that one wrong initially. Well, the second time. So I don't know if you can see my little calculator here. I might zoom in. Okay, so when I rounded initially 0.5 to the 10 divided by 11.7, I got a little bit more. I got a 0.9 instead of, a 2.9 instead of a 2.0 like I should have. But when I extracted my actual number, 11.666, whatever, to 7, then I got 0.552, which it liked, and it didn't like the 0.553. If you get that wrong on a test, just because you rounded before the final calculation, I'll probably just give you the points for it, because that is a little, I don't know. I don't like that so much. Depends on how you round on your calculator as to whether or not you get it right. I'll look into that. You just let me know and say, hey, I rounded before I ended my problem, so I should have gotten that right, and I'll fix it. Okay, this is really terrible, but we only got about 5 problems done, but I'm up on time, so I'm going to stop it, and I'm going to record one more session here.